How many full batches? What do I have? What's my whole number?
So my whole number, okay.
Right here, Kane. Where's my arrow? What's my whole number? Can you not see my screen?
Wait, I don't. Did you just stop for a second?
Can you not see the screen? Hold on, let me reshare it.
I don't see the answer if you put the answer down.
Can you see my screen?
Not yet, but give it a second.
Can anybody else see my screen?
Oh, so it's 6.
Yeah. Okay, so the correct answer would be 6 full batches. Okay?
Okay.
All right. But you can see my screen now, right?
Yeah.
Okay, awesome. All right, guys. So we are going to be on page 247. So 247. If you will open your books, if you have your books, if not, get Seesaw open. And we're on page 247. All right, can everybody see? It says write algebraic expressions to model situations.
I can see it.
Okay, awesome. All right, so your objective today is to use variables to write an algebraic expression to represent a real-world problem. So what that means is we are going to continue with expressions, but now our expressions are going to have letters involved in them. So there's going to be information that we don't know. Okay? All right, so Viola is helping to plant a rectangular community garden. A plant handbook states that one plant requires 8 square inches of soil. Given the dimensions of the rectangular garden shown, how many plants can be planted in the garden? So does anybody have any idea of what do we need to do?
Okay, so these are the questions that you multiply.
Okay, yep, so we're going to multiply the 84 times the 24, yep. And what do we get? All right, so 4 times 4 is 16, carry the 1. 4 times 8 is 32, plus 1 is 33. 2 times 4 is 8. 2 times 8 is 16. So 6.
11, and then, that's 11. You carry the 1. So that's 9. Well, yeah, adding 1. And then that's 2.
Yep, so 2016. All right, now what do we need to do? We need to know how many plants can I get in that area.
You need to divide 2016 by 8.
Yep. Okay, so 8 into 2016. So 8 into 20.
It can go on 2 times.
Uh-huh. So 4 left over. 8 into 41. Should be 5, right?
Oh, yeah, 5.
Which is 40. 1 left over, bring down the 6.
And that can go in time.
Yep. All right, so we can get 252 plants. All right. So the turn and talk says, what happens if the width of the garden were increased to 36 inches? So now, if this is my garden, I have 84 and 36. So how many more plants could be planted in the garden? So we need to do the same process again, right? So 84 times 36. So that's 24. 48, 49, 50. 3 times 4 is 12. Carry the 1. 8 times 3 is 24 plus 1 is 25, right? So 4, 2, 10, 3,024. And then do the same thing. 8 divided into 3,024.
I think I got a question for the other question. I think you got. Did you forget to add the 20 to the 30? Because 4 times 8 equals 32, and you put 336 plus 1,680.
What? You mean up here?
Yeah, I think you forgot a step.
I did?
So 4 times 8 equals 38. You're supposed, and since you added 0.
Wait, 4 times 8 is not 38.
Wait. Let me think. Wait.
4 times 8 is 32.
Oh, that's 4 times 8. Yeah, that's what I said. You forgot to add 2 to 20 to 30.
Huh?
Or was it? So basically, what I'm trying to say is, since you got 320 and then you had 36, you were supposed to wait. 4 times. Wait. Never mind. Sorry, I got that question wrong. Never mind.
Okay. All right.
I thought it was my fault. Never mind. Sorry.
That's okay. It's all right, as long as we can go back and double check ourselves. All right, so the second one is 3,024 divided by 8. So does anybody solve it while I was helping Kane? Well, 8 times...
I was kind of caught up in what he was saying because I was kind of confused.
Confused with what?
With what he was saying. I was like, wait, did
Oh, right. No, yeah. We did it right. Okay. So then 8 times 3 we know is 24. So 24 minus 30 gives me 6. I'm going to bring down the 2. 8 times what is close to 62?
Times 7.
Okay, what does 7 give me?
56.
Yeah. So then that gives me 6 left over again, right? Bring down the 4. And 8 times what gives me 64?
8.
Yep, so 8 times 8. So minus 64 gives me a 0. So if we change the dimensions, we now can get 378 plants. And that was the turn and talk. Okay? All right, so now let's look at how to write some algebraic expressions. Everybody good? Do I need to pause to let you copy?
I'm good for now.
Okay. All right, so let's look at some terminology. All right, an algebraic expression is an expression that contains one or more variables. Okay, so A variable is a letter or symbol used to represent one or more unknown quantities. And a constant is a specific number whose value does not change. And the last one, which is up here, is a coefficient. A coefficient is the number that is multiplied by the variable in the algebraic expression. So let's look at an algebraic expression. So 2x plus 75. 2 is the coefficient. Of course, we know x is the variable, and 75 is the constant. Okay? And then this entire thing is an algebraic expression. Okay? Alright, so how are we going to write algebraic expressions? So a daycare center has 2 baskets of dolls. One basket has 8 dolls and the other basket has an unknown number of dolls. What expression can you use to represent this situation? Can you write a numerical expression? Remember, numerical means we only have numbers. So from this situation, do I have all numbers? No, we're missing some information, right? So I cannot write a numerical expression. So the answer would be no, and it's because we are missing the second basket. So we don't know how many are in the second basket. So what do we know about the situation? So we know that there are how many baskets?
2 baskets.
2 baskets. And one basket has how many dolls?
8.
Yep. The other basket has unknown, yep. An unknown number of dolls. If you do not have all the information you need, could you still write an expression to represent this situation? So we can, right?
Yeah, we can.
All right. So, yes, because we can use a variable to represent the unknown. Okay? All right, so now we're going to look at the bar graph. To represent the information. So it says complete the bar graph and then write the expression. So we know that there were 1, 2, 3, 4, 5, 6, 7, 8 dolls in the first basket. And then this is our unknown, right? So what variable did you guys want to use for our unknown?
Y.
Okay, someone said Y. Sounds like a plan. Alright, so my expression would be 8 dolls plus the unknown. So explain why the expression in part D is an algebraic expression. So why is it algebraic and not numerical? So why is it algebraic?
has the plus sign. It has it's an expression because it has what's called the variable.
Yep, because we are using a variable for the unknown. Yep. Exactly. All right, so what happens to my algebraic expression if we didn't know what the the first basket was? So it says, suppose the dolls in both baskets is unknown. Write an expression for the number of dolls. So what would we do? So if Y is basket number 2, what could I use for basket number 1? Could I use another variable?
I think we could.
Yeah.
We probably could.
Yeah. So I could say X. It could be P. It could be B. It could be Z. It could be whatever letter I want to use. But yes, as long as we identify what that variable is and what it represents, we're okay. So we could let basket number 1 be X, and so my expression would just be X plus Y. Okay?
Okay.
All right, any questions? All right. Moving on. Kristen works at a supermarket. She wants to divide a box of apples equally among 3 displays. Let F represent the total number of apples. Complete the bar model to express the number of apples each display will have. All right, so if the total is F, right, which is 1F, and I split it among 3 different displays, what would I have here? So I have 1, and I'm splitting it into 3.
There's probably a missing step in the alphabet, like the last question.
Well, it's not a missing step. So think about it. I have 1 whole. I'm dividing it into 3. So each square would be what?
Be an X, either X or Y amount of, 1/3.
Yeah, because 1/3 plus 1/3 plus 1/3 gives me 1. Gives me 1 whole. So that means each bin would hold 1/3 of the apples. So if I had, let's say, 33 apples, right? If I had 33 total apples, then this bin would have 11, this bin would have 11, and this bin would have 11. Right? You see how that works?
Yep.
All right.
I guess, yeah.
So we can take this algebraic expression, okay, and this is considered to be the product. Notice, guys, it's 1/3 times F, but am I putting an X there for multiplication? I'm not, right?
No.
Because it looks funny. If I put an X for multiplication, it looks like an X. It looks like a variable. Okay? So in algebra, anytime you have a number or the coefficient next to the letter, the variable, it means to multiply. So we are no longer going to write X's for multiplication. Okay? So the product would be 1/3 F, and the quotient would be f divided by 3. So this is the product. This is the quotient. Okay, so that's what that would look like. Okay, and all we did was, instead of writing the 1 right here, we just took the 1 off and said f divided by 3, because it means the same thing. Okay? All right. Kristen decides to use an additional 12 apples for each display. Not total, but each display. Write a new algebraic expression that represents the number of apples each display will have. Okay, so one display right now is 1/3 f. We're adding 12 to each display. So what would I do to this? We're adding 12. So how would I write that?
If we made a diagram, we could put in like 12, 12, and 12. Basically like 12.
Right. So this one would just be plus 12. This one would be 1/3 f plus 12. And this one would be 1/3 f plus 12. So we only need to write it once. Okay? All right. So what if the algebraic expression changes, right? So it says, how would the algebraic expression change? Instead of putting the 12 additional apples in each display, Christian decided to keep 6 apples from the total before she divided them among the 3 displays. So if each display had 12 apples, what would my total be? So this is plus 12, plus 12, plus 12. So what is my total? 36. Yep. But she's going to take 6 apples off. So now what is my total? 30. Now I'm going to split that among the 3 displays. So how many would each display have now? 10. Yep. So now my new expression would be 1/3 f plus 10. Okay? All right. So look at that check understanding. All right, I'm going to give you about 5 minutes to see if you can do these on your own. Okay? 5 minutes and then we'll check them. Because you are doing the on your own today. It's only a few problems. So we are doing the on your own. So if you are waiting for me to come back and check the check understanding, move on to the on your own. Okay? Don't wait on me. All right, you have about 3 minutes. 3 minutes. Two minutes. 2 minutes.
You on here only has 6 questions, right?
That is correct.